Hey there and welcome. Today we are going to talk about solving a little bit harder two-step equations and inequalities while still checking our answer. Now, it says harder because it just looks a little more complicated. It's not actually harder. There's still only two inverse operations that we need to apply in order to solve them. But let's go ahead and get started. All right, so here is our first problem. Here we have n plus 5 all divided by negative 16 equals negative 1. So the first thing that we should identify is our variable, which in this case is n. And now we need to say what's actually happening to it. So right stuck with it, I can see that I am adding 5. So my inverse to that is going to be to subtract 5. And then I also see that I am dividing by negative 16, which means that the inverse for that is to multiply by negative 16. And I also like to do my circle of don't touch, which for the purpose of two-step equations is always my variable and whatever's stuck with it. And so n plus 5 is my circle of don't touch this time, because the entire thing is part of my numerator. So because it's part of my circle of don't touch, right now I can't do anything with this section, which means I have to multiply both sides by negative 16. So I'm going to multiply negative 16 over here. I'm going to multiply negative 16 over here. I'm going to erase that so I don't forget. And now I'm going to simplify. So I have negative 16 in the numerator, negative 16 in the denominator, and those just give me a real fancy version of 1. So up top, I'm left with n plus 5 equals negative 1 times negative 16 is a positive 16. All right, so that part's done. I've checked it. Next thing that I need to do is to now subtract 5, because that's what's left in my table of inverses. So I'm going to subtract 5 over here. I'm going to subtract 5 over here. Nothing happened to my n, so I'm just going to bring that straight down. 5 minus 5 gives me a nice big 0. Equals 16 minus 5 gives me 11. Now I have my variable all by itself, and it's a positive variable. Right, it's not negative, it's positive. So now I have an answer. Now I need to check to actually make sure that it's correct. So we're going to check. And I always like to write down the number that I'm checking just so that I'm less likely to make a mistake. So I'm going to start by rewriting the original problem. So I had n plus 5 over negative 16 equals negative 1. And instead of n, we are substituting it with 11. All right, I'm going to scroll down just a smidge so I have room. So now I need to simplify what's up top. 11 plus 15 gives me 16, divided by negative 16 equals negative 1. Positive 16 divided by negative 16 is negative 1, which equals negative 1. And that is true, that is accurate. So in the grand scheme of this problem, n does in fact equal 11. So that problem wasn't too bad. It looks a little scarier just because the fraction is a little bit longer, but it still just took us two inverse operations to solve it. So let's move on to a new one. All right, and this one is an inequality. So first things first, we still need to identify what our variable is. It's right there, it is k. And what is happening to this variable is that we are adding 9. So the inverse of that is subtracting 9. And we got to remember that when we have a number on the outside of the parentheses going to something inside the parentheses, that's multiplication. So we are multiplying by 7, so the inverse is to divide by 7. So with this problem, in reality, there's two ways that we can go about it, and it's really your choice on how you start. You can either choose to start by distributing that 7 to both of those terms and then solving the two-step equation. Or, because we know that we're multiplying by 7, we can start by dividing by 7. Because in reality, since this is inside parentheses, that is my circle of don't touch. So I'm going to divide both sides by 7, because that's what the inverse really is telling me to do. So 7 divided by 7 gives me a fancy version of 1. I'm left with 9 plus k on that side is greater than. Now I have to figure out what 84 divided by 7 is. And if you don't know, that's totally fine. Write it off to the side. 84, 7 goes into 8 once. We subtract, we're left with 1, bring down the 4. 7 goes into 14 twice, so we end up with 12. And if you already knew that, then fantastic. So now, we have divided both sides by 7. All that's left for us to do now is to subtract 9 from both sides. So 9 minus 9 gives me a big fat 0. I'm going to bring down my variable. Keep your sign. If we don't start with an equal sign, we can't end with an equal sign. And 12 minus 9 gives me 3. So now I have an answer. We need to check to make sure that it's the correct answer. So I'm going to do my check. And again, I like to write down the number that I'm checking just to make sure I don't mess up. And I'm going to start by rewriting the original problem. So we had 7 times the quantity, 9 plus k is greater than 84. And instead of that k, we are going to substitute it with 3. And now we're just going to follow order of operations. So I need to do the math inside those parentheses first. So I'm going to have 9 plus 3, which is 12, is greater than 84. Now we actually have to do 7 times 12. So again, if you don't know that off the top of your head, write it off to the side. 7 times 2 is 4, is 14, so carry the 1. 7 times 1 is 7, plus 1 is 8. So now I've proven that 7 times 12 is in fact 84. So I get 84 is greater than 84. And while this is not a true statement, 84 is not bigger than itself, because I have the same number on both sides, that tells me that 3 is actually the correct number. Right? So I count this as a good check. But now we need to see if we actually have the sign going in the correct direction, right? Does k need to be a number bigger than 3? And so we need to check a number. You can check a number that's bigger. You can check a number that's smaller. That's completely your choice. Personally, my favorite number to check is actually 0. Ooh, let's pretend that looks like a C. So I'm going to actually check 0, which in aspect of 3 is smaller. So I'm going to write small to remind myself that I'm actually checking a smaller number. I'm going to rewrite the problem. So 7 times 9 plus k is greater than 84. Instead of that k, I'm going to substitute in that 0. So I have 7 times 9 plus 0 is 9, greater than 84. 7 times 9 is in fact 63. And so this says 63 is greater than 84, which is false. That's not true, which means our answer cannot be smaller. It must be bigger. So when I look back at the answer, I have to see, does this say k is greater than 3? And it does. K has to be bigger than 3. So now I have my answer. I've proven that my sign is going the correct way. Now all I have left to do is actually graph. So when I make my graph, I need to make sure that the number that I got for my answer is on my number line. Since it's just greater than, that's going to be an open circle. And I need where the numbers are going to be greater than 3, bigger than 3, which is always going to be off to the right. And so that's it. We've learned how to solve those harder looking two-step equations with equations and inequalities. We've done the checks, and on the inequality, we graphed. So until next time, I'll see you later. Love you, bye.